When we take measurements in the lab, there are two things we have to consider: significant digits and uncertain digits. Okay, significant digits or significant figures are our way of figuring out what numbers to count and what we don't when we start doing calculations. In the measurement itself, it doesn't affect much to know how many significant figures or digits something has, but when we go and use that number for a calculation, it's imperative to know how many significant figures there are, how many significant digits there are, in order to make our calculation consistent with the level of precision that we know for our original measurements. In other words, we can't be more accurate than our original measurements tell us. Just because our calculator puts out a number with 6 or 7 spots in the decimal place when it calculates, it doesn't mean that we know that for sure out to that far in the decimal place. So that helps us to kind of keep track of that. Now, what we're going to be looking at in this case is uncertain digits. In other words, where we have to kind of say, we can only read so far between the lines, and we have to cut off our measurement there. So we're going to start by looking at some glassware and some materials you can use to take measurements in the lab, like, say, this beaker here. Okay, so this beaker has these lines, we sometimes call it demarcations or graduations. So these lines are either going one way or the other. So you can either look at it like on the right side, which we would mark as TC, or to contain. So in other words, this tells us how much liquid we are containing in this beaker, and we're measuring volume here. So this is measuring in milliliters, as it shows kind of by the little ml. All right, so on the right side, this 20, 40, 60, 80 is counting up in milliliters, okay, how many we can contain here. On the left would be sometimes marked as TD, or to dispense, so how much volume you are letting out as you pour some out and you recheck the number. Okay, so most of the time with glassware like this, we're looking at how much liquid's contained in it. And this beaker can hold up to 100 milliliters, but that doesn't necessarily mean it measures up to 100 milliliters. You notice that the marks stop at 80. Okay, and not only that, but our marks looks like we don't even have a 10 mark. We go kind of from nothing to 20 to maybe what's in between 20 and 40 is 30, and then from 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80. Okay? If we want to try and figure out the volume that's inside this beaker, we typically look at the bottom part of the curve of the water, or whatever liquid we have here, okay, rather than looking at the top or at the middle. We call that the meniscus of the water, and your glassware is going to be calibrated to measure things based on that bottom line of the water, not the top or the middle. Okay, so based on our lines here, this is above the 20 line, so it has to be more than 20 milliliters. It's above this 30 line, so it has to be above 30 milliliters, and it's below 40, so it has to be between 30 and 40. Now, in between here, we have no more lines to kind of split hairs of where we are between this. So this could be 35 milliliters, it could be 36 milliliters, it could be 32 milliliters. It's kind of hard to say. It kind of depends on how you look at it. Okay, so this is the point of uncertainty, where we can no longer say for sure we know how this measurement is. So in other words, we know for sure it's going to be between 30 and 40, but we can't say for absolute sure whether it is 35 or 36 or 37 or 36.5 or 36.5555, 2527, who knows? And we can't claim to know that either, no matter how good your eyes are. We can't add marks to the beaker or something and say, I'm just using this here. Well, that's not how the glassware is calibrated. So the best we can do is say this is something between 30 and 40 milliliters. Now, we don't usually just say somewhere between 30 and 40. We have to pick a number, okay, where that last digit that we write is going to be our uncertain digit. So in this case, we're starting to get into the uncertainty when we go to that ones place. Okay, so the tens place is pretty certain. It's going to be something like 30 and above. But where it is from there is kind of uncertain. So when I say 35 milliliters or 36 milliliters, that 5 or 6 in the one spot is uncertain. That would be my uncertain digit, okay? In general, that uncertain digit is usually kind of the last number, the last digit in your measurement. It usually is the last thing you have to kind of split hairs and read between the lines on. Okay, so even though I can go between 30 and 40, and that includes the ones place, we don't really know for sure anything past that. There's nothing that allows me to figure out anything in between the ones place to get down to like the tenths place. So our uncertain digit is going to be in the ones place, like the 5 of 35 or the 6 of 36. Now, depending on what glassware you use, you might have different cases of this. So these are a couple of graduated cylinders. They are cylinder shaped, and they have marks on them we call graduation. So they're graduated cylinders. So this guy has a water level containing somewhere between 60 and 70 milliliters. But this also has more lines on it. So if we get a little bit closer here, let me see if I can get this to focus. I'll pull it back a little bit. Okay, that's a little bit better. All right, so what we're reading here is there's lines between 60 and 70 that look like there's 10 of them. So it goes from 60 to 61, 62, 63, 64, 65, 66, 67, 68, 69, 70. So each of these little lines in between 60 and 70 count as one, where 60 is sitting on that line and 70 is sitting on that line. So I know for sure that my measurement is above 65 and even above 66 milliliters. And then from there it gets a little foggy, whether it's right on 67 or a little bit below. Okay, but I know for sure where 66 and 67 are, and it looks like my meniscus, the lower part of that curve of the liquid, is between those two. So in this case, I know the one spot for certain. I have 66 plus some, or I have a little less than 67 milliliters, so I could say maybe 66.5 milliliters, or 66.3, or 66.7 milliliters, where that tenths place, the 0.3 or the 0.7 or the 0.5, is going to be my uncertain digit. Okay, so I could go out a little bit farther on this measurement than I would in the case of the beaker. Let's look at another example with another graduated cylinder. Okay, so these ones have lines for ones. Okay, so this is going from 20 to 21, 22, 23, 24, 25, just like the other graduated cylinder. So in this case, we are sitting, let me see if I can get this on eye level a little bit better. Okay, that is like darn near on 25. Okay, now if I wanted to say this is exactly on 25 milliliters, I wouldn't just say 25 and then stop there, because I can know out to the tenths place here, or at least I can kind of guess and read between the lines here. Okay, so if I want to say this is right on 25, but I could know that it's between 25 and 26 if it was there, that means I could say 25.1 or 25.2, and so I should include that uncertain digit to show that. So even if you are right smack dab on a number, you can go out to your uncertain digit every time to show that you have that level of precision in your measurement. If you just say, 25, we don't really know for sure if that means, well, is that the best we could do? Can we not read between the lines any better than that ones place? Or were you smack dab on? So we always include that uncertain digit. In this case, we would say 25.0 if we're settling on being right on 25, right on there. Okay, now let's look at another one. Okay, yet another graduated cylinder here. Let's see if I can get this to focus a little bit. Okay. So this one, it looks like we are sitting above the 5 line, and it looks like we've got lines for something, but they're not ones lines. It's like there's 5 of them in between the 5 and the 6. So it must be 5.2, 5.4, 5.6, 5.8, and then 6.0. So on the 5 line would be 5.0. That line above it where our meniscus is sitting is about 5.2. Okay, now I know for sure that that is the 5.2 line. And the one above it would have to be the 5.4 line. Now in between that, I could say that could be 5.3, but could I say it's 5.35? That's kind of stretching it a little bit. Okay, so even though this does go out to the tenths place, so I can say 5.2 and 5.4, I can't really read between the lines and say for sure that this is 5.21 or 5.23, because the 0.3 and the 0.4 are kind of not really shown here. I'm not going by ones, I'm going by, or not going by tenths, I'm going by like, well, 2/10 in a sense. Okay, so this is kind of a tricky one. So what I would rule this as is that our uncertain digit is still in the tenths place, where we have to say 5.2 or 5.3 or 5.4, and we can guess out that far, but we can't guess any farther, okay? Because otherwise we're kind of lying to ourselves, okay? If we can't tell for sure exactly where 5.3 is, we can't really say that we know for sure where 5.25 is. That's kind of cheating it. Okay, let's look at some other examples. So those were a lot of kind of to contain examples. So glassware that's kind of measuring upwards to contain some liquid. Let's look at some others. All right, so this guy is a syringe. And right now it's upside down, but I'm going to turn it right side up. Okay. Now some things it's not totally clear from the beginning where you're making your measurement at. So in a syringe like this, we have kind of a tapered end, and then we're going down 10, 20, 30, 40 in this direction. So it's kind of counting downwards, which is kind of interesting. Okay, now, do we count where the tip of that rubber is right there? Or do we count on this black flat line here? Or do we count on this black flat line below it? Well, it doesn't really say on here if you turn it around. Okay, what I would say is going by this kind of black line at the end of the rubber, but not on the tip of it. Okay, that's a point that we can tell for sure lines up somewhere on the syringe. It's probably kind of measured to be there purposefully. Okay, so this one looks like it's sitting right about on 39. Okay, now you got to be careful because we're counting down in this case. Some people will see this 40 and they'll see this line here and say, ah, this is 41 milliliters. Not so, because up here is 30. This has to be somewhere in between 30 and 40. So if we say this is 41, then we're going in the wrong direction. 41 would be right here underneath the 40. So since we're counting downwards in this direction, be careful. This is going to be 30, 35, 36, 37, 38, 39. Now in this case, since we do have like a 0.1, a 0.2, a 0.3 for every tenths place, we could say for certain that we have 39 milliliters, and then go one uncertain digit after that to say 0.0. So we could say this is 39.0 milliliters. So I'm going to hang that back up. Okay, let's look at some other things. All right, this guy here is a gas measuring tube. Oh, let me go to this one. This is a gas measuring tube. So we sit it in some liquid, and then it should have marks on it that tell us not how much liquid is in it, but how much gas is in it. Okay, so let me come over to the other side so I can see the numbers a little bit better. Okay, now I'm not sure I'm going to be able to get this to focus well enough. I'm going to have to get up on the table a little bit. So the inside is kind of foggy and the lines are white, so it's probably not going to come out very well in the video. Ooh, okay, I might have hit the sweet spot there. Okay, so hopefully you can kind of tell that this has numbers counting down also. Okay, in this case, because our air is at the top, or whatever gas you capture is at the top, and your liquid's down at the bottom. We don't really care about the volume of the liquid, we care about the volume of the gas in here. Okay, and it would make more sense to measure the volume of the gas that you collect in here going downwards. If you were to have more gas, it would fill up going down this way and keep pushing more liquid out. And if you had less gas, it would be up here. So it wouldn't really make sense to make the highest numbers at the top. We want to have the highest numbers at the bottom, where we have more and more gas pushing the liquid out. Okay, so in some cases we have numbers read downwards because it helps us figure out how much liquid is going to be dispensed. In this case, it just fits the sense of measurement better. The reason why we're measuring this is because we want to figure out how much gas is in here, and it makes more sense to do that downwards. Okay, so if we collect more gas, it's going to be kind of increasing our measurement going down this way, and this one goes to about, well, let's see, it looks like it's in between 12 and 13. If we count the lines in between, there are 10 between each of these, 12, 13, 14, and things like that. So if we look here, we're going to about 12.1, 12.2, That might be on 12.3. So it looks like maybe the 12 point, well, it kind of, so this is where it's going to be hard for me to do, holding the camera and reading at the same time. From my point of view, and I think what I'm trying to capture in the camera, is this is sitting at about 12.3. Okay, now in this case, all these 0.1s, 0.2s, 0.3s are given out to us. Okay, so not only can we split hairs on between 1 or 2 or 3, we can split hairs in between 12.1 and 12.2, or 12.2 and 12.3. So we can actually go out one more digit into our uncertainty to say that this is not just 12.3, this is 12.30. Okay, in other words, I have some guessing room in between 12.2 and 12.3, or between 12.3 and 12.4. I know for certain where 12.3 is, and I know for certain where 12.4 would be. So I can say this is 12.30 if it's landing right on 12.3. Okay, I can have 2 spots after the decimal place and go out to the hundredths place because I know the tenths place for certain. So therefore, the next digit out should be my uncertain digit. Okay, let's look at some other examples. Okay, while we're here, let's come over to this guy. This guy is a burette. Now, its goal is to dispense a certain amount of liquid. Okay, we have a valve here at the bottom which we can use to control how much liquid comes out the other end. And if you look up at the top where our numbers start, again, if I can get this to focus here, okay, you'll notice that the 0 milliliter mark is up at the top, okay, and it goes down from there. Okay, so we usually use this to figure out how much liquid we've put out into something else. So you know your starting mark, and then you empty some liquid out, and the level gets lower, and so you know the difference between those two levels is how much liquid you released. If you start right on the 0, then it makes it easy for you. Okay, now also I want to point this out, if I can get it again to focus. There is a little TD right there, okay, which means to dispense. Okay, in other words, that's why we're kind of counting down here. Okay, so if we can get this to focus here. Close. Okay, so that's 19, and again, we're counting downwards, so be careful. So all right, if I'm seeing a line above the 20 mark, then that's not saying like 20 point something. I'm actually going downward, so it should be 19 point something. Okay, so this is going to be about 19 point, okay, 19.123 maybe. 19.3. Okay, I want to move the camera so I can see it with my own eyes a little bit. So ignore the fact that I'm just pointing the camera at nowhere for a second. Looks like about 19.4. Okay, now again, since each of these lines is a tenths place, we can actually go out to the hundredths place. So we could say 19.40 is our volume here. And you want to include that uncertain digit whether it actually strays out into the hundredths or not. Okay, so if you land right on like 0.4 or 0.5, that's okay. Just make sure you include the 0 after it to show that you could know out to that farthest uncertain digit in the hundredths place. Okay. Let's go over to a versatile piece of glassware, which is this guy right here. This is a serological pipette. Okay, a pipette is just something that's used to draw up liquid. There's a bulb up here at the top that's used to suck liquid up and also shoot it back out. Okay, and the side that I have this facing on right now, if I can get this to focus, has some very small, tiny numbers. So like there's a 10 right there. There's a 9, there's an 8 right there, and there's a 7, and a 6, That came out nice and clear. Okay, now these little lines that you might be seeing are actually just on the other side. Okay, these are counting downwards. Okay, whereas these are counting upwards. Okay, now even though it kind of looks like these tens lines are lined up with this, it's kind of hard to say whether we can use those or not, since they're on the other side of the glass. So depending on how you are on eye level, it might not be the best way to measure this out. So on this side, where we're counting upwards with how much volume we're containing, this is really good at figuring out the volume at very specific ones milliliters. So like at 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9 or 10. Okay, but as far as something in between, it doesn't really tell us. Okay, again, you could try and go with the numbers behind, where you've got kind of the 0 and the 1 and the 2, but those are meant for how much liquid you're dispensing. And they're not on the same side as the counting up numbers. Again, it's kind of hard to show that, because the glass is translucent, and you'd be able to see it better if you had it in front of your own eyes. But this is one way to kind of show it. So as you're looking at kind of an angle, you can see them on the right, but they're not on the left. So looking from the front, you can see the marks on the back, but they might not exactly correlate well to the front. So we probably don't want to use this for any measurements where we need to know something like 9.5 milliliters or something like that. A graduated cylinder might be best suited for that. But if we need exactly 9 or 10 milliliters on the dot, then this would probably be okay. Now, if you're working on dispensing a certain amount of milliliters, then you can go to the back side and look from the 0 down to the 1, down to the 2, down to the 3. And since the marks are on this side with the numbers, you can have a little bit more certainty in your 0.1, 0.2, 0.3 as you go downwards. And therefore, you can read between the lines a little bit to get into the hundredths place. Okay, so sometimes, depending on your glassware, it's not so easy and clear to figure some of this stuff out. But most of the glassware we use in the lab will kind of either be pretty clear and straightforward, or you can always ask and talk about how we figure out the uncertainty of the measurement. Okay, now a couple other kind of strange examples. Let's say you have a container like this, okay, where your markings stop, but you have liquid above that. Can we kind of eyeball that and say, well, okay, between the 400 and the 500 is 100 milliliters, and this looks like it's less than the 50 milliliter kind of difference between 450 and 500, so maybe this is like 530 milliliters and we ballpark it. Not really. Once we get past the line where we're making the measurements, that's kind of invalid. Now, even again, if you have really good eyes, maybe you try and measure it out with a ruler or something, do some kind of ratio. I understand, but it's best just to remeasure the liquid in something that fits the appropriate amount of stuff you have, okay, rather than trying to eyeball it from here. Okay, so if your measurement is past the point of what we actually have marked on your glassware, it's not really safe to say we know how far past that we are. And that goes for things like glassware that's made to dispense stuff. So on your burettes, you have a mark for 0.0 up here, but we don't want to try and guess and say, well, if you're above that, maybe it's like at negative 1.0 or negative 0.5. We just can't tell for sure, and the glassware isn't calibrated to be like that. So it's not really safe to make a measurement being that so cavalier about it. Okay. Now, we also don't have to just take measurements for volume. We can take measurements of other things. It just happens to be that a lot of the glassware we use in here is used to measure volumes. Okay, so you can even do this for a thermometer. So this thermometer here, let me see if I can rotate it a little bit. Ooh, come on. All right. So this thermometer has some markings on it. Okay, so let's see. So this is above the 50 mark, and it's counting upwards. We do have some little demarcations here. Looks like there's 10 of them between 50 and 60, so that's going to be ones places. So right now, this is going above 51, 52, 53. This is sitting at about 54. Now, if it's a little bit above or below that, since we have the ones place for certain, we can do the tenths place as our uncertain digit. So you could say 54.1 or 53.9. But if you say it right on 54, don't forget to include that uncertain digit, 54.0 degrees Celsius. Okay, and then just be sure you know which temperature scale you're using. Typically, we use Celsius in the lab. If you're using Fahrenheit, how dare you? Or, well, you know, maybe you just don't have the right thermometer for it. But typically, we'll use Celsius. Okay. Now, there is another kind of glassware I want to talk about, which is this guy. This is a volumetric flask, and you might also come across volumetric pipettes that don't have any other lines on here except this one line. Okay, now that one line has a very specific purpose, and that is to tell us when we have exactly a volume of whatever is written on this glass here. So right now, this is TC for to contain 100 milliliters. And this line is meant to show exactly 100 milliliters of volume. If you have a liquid level anywhere else in here, we have no clue what that volume is, okay? Especially when it's all bulbous down here. You know, who knows where the volumes are for that stuff? Okay, but when you are right on this line, you have exactly 100 milliliters. Now, like with any measurement, there has to be some level of uncertainty that we don't know. But since we don't have extra marks on here, we can't just say, well, you know, I can see the ones place, so I can go to the tenths place, or I can see the tenths place, so I'm going to the 100th place, and we just go one spot past what we do know. In this case, you just have to kind of know that you need 2 decimal places out from whatever you're measuring. So if this is an 100 milliliter volumetric flask, we can say that this has exactly 100.00 milliliters of liquid volume in here. Okay, so some glassware is a little bit more specific, and you might have to go digging and research a little bit to figure out where you make your kind of uncertain digit go out to. So then same for volumetric pipettes, they should go out to 2 decimal places. So if you have like a 25 milliliter volumetric pipette, you should be able to say that at the line you have exactly 25.00 milliliters. Now, I'm not saying that that goes for every single volumetric flask and volumetric pipette. You should always go and research and double check somewhere, but that's a pretty good rule of thumb as it goes out 2 digits at the decimal points. Okay, now to wrap this up, let's talk about a couple last measurements that we can make that, again, aren't volume-based, kind of like how we can make temperature measurements.